Okay, so let's talk about pressure units and the AP exam. So there's a lot more possible pressure units that exist out there from both chemistry and physics than what the AP test actually uses. So the primary unit that is used in AP and in chemistry in general here in the United States is atmospheres. And we abbreviate atmospheres with ATM. So when you see that, that's what it's talking about. That is pressure unit. The next most common one you will see in AP chemistry is millimeters of mercury. And that is literally given as mmHg. And that millimeters of mercury does come from the barometer that you saw in the last video. Now, here in the United States, we don't use millimeters of mercury. You will actually see, if you ever watch the weather, and they're talking about the barometric pressure, which is another way of saying the atmospheric pressure, talking about changes in the pressure, and is that indicating a storm? Those numbers that they're giving, 29, 30, 33, those are actually in inches of mercury instead of millimeters of mercury, because this is the US and we don't do metric. So those are the most two common things that you will see. Then there's this thing called the torr, Torr, which is literally just the torr. And torr comes from really Torricelli or Torricelli, and that's the guy who came up with the mercury barometer. So they actually named a unit after him. Then you have pounds per square inch. That's what you're going to see on tires, basketballs, things like that. That's what PSI means, pounds per square inch. And then there is kilopascals, and that's the actual SI unit for pressure, and you'll see kPa. And physics uses kilopascals almost exclusively, and to be quite honest, the rest of chemistry outside of the United States also uses kilopascals, but AP does not really use it. They are very much focused on these first two units here. Those are the ones that you're going to see most often. Now, what do these things all equal? Well, at sea level, you're going to see these values. 1 atmosphere at sea level is standard atmospheric pressure. We already know that is equal to 760 millimeters of mercury. And here's an interesting thing. Since Torricelli developed the barometer that's measured in millimeters of mercury, those two units are exactly the same. So 760 millimeters of mercury is the same thing as 760 torr, which means that those two units are completely interchangeable. They're exactly the same, which is why some rare occasions you will see something given in torr and you can just in your head think, okay, that's millimeters of mercury, done. PSI. 14.7 psi is standard atmospheric pressure. And for kilopascals, we typically use the value 101.3 kPa, although sometimes you will see number values with different numbers of significant digits there. Okay. So these are all of our equalities here, and you can make a conversion factor between any one of those things, right? If two different values are equal, then you can put them in a numerator and denominator to be able to do conversions. So for instance, 1 atmosphere over 760 torr is the same thing as 760 torr over 1 atmosphere, or let's say 14.7 psi over 101.3 kilopascals. And that would be the same as 101.3 kilopascals over 14.7 psi. So the nice thing is all of these values are on the AP formula sheet. So you don't have to memorize them, although it's not exactly difficult. And again, these are going to be your most common pressure units that you're going to have to use. Although since the text we're using is from Canada, you are going to see this kilopascals on these worksheets a little bit more often. And in practical everyday use, PSI is actually the more common thing for us here in the States. Again, almost exclusively from tire pressure. So let's make sure we can actually use these equalities to do some practice conversions. So I've got two problems for you. All right, so the first one, the pressure on the top of Mount Everest averages 235 millimeters of mercury. So that's my given right there. I've got that. That's my given pressure. And it wants me to convert that into torr, PSI, atmospheres, and kilopascals. So that is 1, 2, 3, 4 problems all in one. Now, Mount Everest is typically considered to be the tallest mountain in the world, so it makes sense that it would have a very small atmospheric pressure. That 235 millimeters of mercury makes sense. So let's go ahead and do these problems. So number 1, going from millimeters of mercury to torr. Well, guess what? That is the easiest thing to do because 760 millimeters of mercury equals 760 torr. So I'm just going to rewrite my answer and say 235 torr. Done. Okay, the second problem. PSI. Okay, so if I'm going to go from millimeters of mercury to PSI, that conversion is between 760 millimeters mercury and it's going to equal 14.7 psi. So I'm going to start with my given, which is the 235 millimeters mercury. And if that's in my numerator, then in my denominator, I need to have the 760 millimeters of mercury, and I need the psi in my numerator. So that's going to show that my millimeters of mercury cancels out, leaving me with psi. And if I do that in my calculator, that's going to read 235 times 14.7 divided by 760. And how many significant figures should I have? 1, 2, 3 from the 235. So that's going to be 4.55 psi. Okay, for the next problem, converting that into atmospheres. Okay, so millimeters mercury into atmospheres. Again, so 760 millimeters of mercury equals 1 atmosphere. So 235 millimeters mercury times, again, millimeters mercury is in the numerator, so I need it down the denominator. So my 760 millimeters mercury goes in my denominator, and my 1 atmosphere goes in the numerator. Millimeters mercury cancels, leaving me with ATM. Do the math. 235 times 1, which doesn't do anything, divided by the 760. Again, I have the 1, 2, 3 significant figures, and that would be a 0, which does not count for a sig fig. 309 atmospheres. And for my last problem here, let's raise this up, give me a little more room. Okay, so for my fourth problem, I've got 2 kPa, so millimeters mercury, 2 kilopascals. So 760 millimeters mercury equals 101.3 kilopascals. So same sort of thing here. Move this a little bit more. Okay, so 235 millimeters mercury. That's in the numerator, so my 760 goes in the denominator. My 101.3 kilopascals goes in the numerator. Cancel, cancel, leave me with the correct unit. And when I do my multiplication, 235 times 101.3 divided by 760, I had 3 sig figs in the original number, so to 3 sig figs it would be 31.3 kilopascals. Okay, so those are straightforward problems, and you might be asked to do a conversion like that as part of a larger gas law problem like you'll see in sections 8.2 and 8.3. But I did want to cover a kind of weird kind of problem that you saw in this section. It's the bicycle question. So in bikes, when you have your tire, right? So you've got your tire, you've got your spoke, whee, there's your bike wheel. So this tire has a certain amount of air pressure. And that air pressure, when we read it on a gauge, it's that air pressure plus atmospheric pressure. That's what the gauge reads. So if the tire needs to be at a pressure of 125, that's the air pressure, 125. And that means that the gauge is going to read that 125 plus 14 psi, which is this atmospheric pressure. So that means we're going to have to add those two things together first. So 125 psi plus 14.7 psi. Add those things together and you'd be like 0.79, 139.7 psi. So sig figs here. This is addition. And in addition, remember we go to the lowest number or the least number of decimal places. That's the least number of decimal places. So we need to go to this spot here. So that means that this number is actually going to be 140 psi. But how do I show that that one is significant? I'm going to put my little decimal point there. Okay, so that's my pressure. And I need to convert that pressure to kPa and millimeters of mercury. So again, one problem, two problems. So for the first one, I'm going from psi to kPa, which means 14.7 psi equals 101.3 kPa. So I'm going to start off with my 140 point psi. I start with psi, so I have to divide by my psi and divide by, or multiply, my numerator, 101.3 kPa. Again, units cancel, leave me with the right thing. I have 3 significant figures there in that 140, right? Remember, that's why we put the decimal there. So 140 times 101.3 divided by 14.7, 3 significant figures. That's going to give me 965 kilopascals. All right, that's a lot of pressure. So converting that psi into millimeters of mercury, 14.7 psi equals 760 millimeters of mercury. So again, 140 point with my 3 significant figures there. Start with psi, divide by psi in my denominator. My numerator is going to have that 760 millimeters of mercury. My units cancel, giving me the right thing, so I set it up right. I want 3 sig figs, 140 times 760 divided by 14.7. So to 3 sig figs, let's write this out. It's 7238 millimeters of mercury. But where do I do my sig figs? Well, 1, 2, 3. So I need to cut it off here. This makes me round up. So that answer is going to be 7, 2, 4, 0, because I have to make sure that this stays as a placeholder 0 there, millimeters of mercury. So don't forget how to apply your sig fig rules.